Before we go to that, let's try to understand the difference between combinational logic and sequential logic. Combinational logic output depends only on current inputs. Sequential logic output depends on current inputs and the current state. One of the primary difference you will see in sequential logic is clock will be there. Here clock won't be required. A combinational logic, if I draw AND gate, do you generally give clock as an input? No, right? Whereas if you take any sequential logic, clock is compulsory. To implement a combinational logic, you can even use C language. Up to combinational you can use, because a combinational logic don't have a concept of time, hence C language is also sufficient. Anyway, not to confuse you much, we'll start from the very basics. Okay. We are going to implement all of these things. If you feel that something is missing, please let me know. What do I mean by missing? During digital, our trainer has taught me this circuit, but it is not there in the list. You can tell me, we will do that also. So first let's start with a very simple thing, that is half adder. All above circuits we will implement in three modeling styles. One is behavioral, one is data flow, one is structural. Okay. So what exactly are these three? I'll explain you. See, behavioral means high level, structural means low level, data flow means mid level. For now, understand in that manner. Maybe one or two sessions later, you will understand what exactly is what. So first let's start with half adder. Let's start with half adder. Can you draw the simple diagram for a half adder? If I tell you this is half adder, how many inputs will be there for a half adder? What are those inputs? A, comma, B. What are the outputs? Sum, comma, carry. So when it comes to Verilog implementation, you just have to remember how many ports are there, what are their directions. So that will translate into the structure. Half adder dot V. What is the name of the file? Half adder. V means what? Verilog. Like C program, you end with dot C. C++ with dot CPP. Same is. Now first thing what I have to do? Module. Everything in Verilog is a module. Every block is a module. If I have to tell laptop as a Verilog code, module laptop. Like that. Everything in Verilog is a module. What is the name of the block here? Please remember this. I will ask you to do full adder. Okay. Now after this. Whenever you write module, you write the opening brackets and just say end module. Clear? Then here you have to write the list of ports. What all ports do you see in the diagram? A, comma, B, comma, sum, comma, carry. Now comes the simple thing. What is the direction of A? Input. Output. Sum, comma, till this point, is it clear? Nothing complex, right? You just have a design where you know the directions. Without knowing these things, will you be able to do this? Right. So that is where your understanding has to start from here. First, you should be able to visualize a half adder will have two inputs, two outputs. That you have to write. Next. What is the Boolean expression for half adder sum? A XOR B. Carry. This one. We can simply do it in this manner. Assign Sign. XOR has a symbol. What is symbol of XOR? Cap. And what is symbol? That's all. This completes the half adder Verilog. Nothing very complex. Whatever you learned in digital, you just have to put it. What did I do? I wrote the same expressions. We have to use a simple concept called as assign. Assign means, what is meant by assign is, anytime, assign means, anytime A or B changes, S and C gets updated automatically. You understand what does assign will do? Anytime A or B changes, S and C gets updated automatically, immediately, and immediately also. Same time it gets updated. That is how half adder works, right? Anytime you change the output, inputs, output also gets changed immediately. This style of modeling is called as data flow style. What is meant by data flow? A and you are XORing A comma B, that is going to S. You are ANDing A comma B, it's going to C. It's like a flow of data. Can you see data is flowing from one point to other point? That's why it's called as data flow modeling. Data is going from one point to other point. This style of modeling is called as data flow style. I will do one thing. Is it correct? It is wrong. How do I prove that it is wrong? How do I prove that it is correct, or how do I prove that it is wrong? That is where we need a concept of simulation. We need a concept of simulation for that purpose. What the simulation will do? As part of simulation, I have told you two things. We apply inputs, we get the outputs and check the outputs. We will apply different values of A and B. We'll apply different inputs A and B and check whether sum and carry comes properly or not. Based on that, we can confirm that either this is correct or this is wrong. So that process of applying inputs, collecting the outputs and checking the output, that whole process is called as simulation. Someone who does that is called as simulation process. So let us do that. To do a simulation, what is the primary requirement? I need to apply the inputs. The component which generates the inputs is called as test bench. So I am now going to develop a test bench. So let me first show you how does a test bench looks like. So what are the two things a test bench does? Generate and apply inputs to the design, collect the design outputs, check those against the expected values. Please read it again. How many things test bench does? Two things. What is the first thing? Generate and apply inputs to the design. Second thing, collect the design outputs, check those against the expected values. Okay. I'll be asking the same thing after 3 months. I want you to tell the same answer. Means throughout as a verification engineer, these are the only two things you do. Whenever someone says they're developing a test bench for a big design also, they're still doing the same work. What are the two things they're doing? They're generating and applying inputs to the design. When you apply input, what will happen? Output will come, right? That output you check whether it is coming as per your expectation or not. Okay. Let's say someone with 15 years experience in Qualcomm or Intel, who is developing a test bench, he is also doing the same work. What is the work he is doing? He is going to generate and apply inputs and is going to check the outputs. Just that the type of inputs you apply will differ, right? See, my laptop will require a different type of inputs. Mobile phone will have a different set of inputs. A half adder will have a different inputs. Because of that, the pattern of inputs you apply will differ. But the fundamental concept remains same. What is the fundamental concept? Generating and applying inputs is one common thing. Second thing is what? Collect the design outputs and check those against expected values. Is the fundamental concept every test bench does. The most complex test bench or the simple test bench we are going to develop now, both does the same work. Even when we learn system Verilog, even when we learn UVM, the concept of test bench doesn't change. Then what is changes is the way you generate and apply inputs will become simpler. The way you collect the outputs and way you check them will become simpler. As you go from Verilog to system Verilog, generating inputs will become easy. The way you do it, collecting outputs will become easy. Checking will become easier. Again, when you go to UVM, it becomes even more easier. But the fundamental concept of a test bench remains same. So now let us start with developing a very simple test bench. Test bench half adder. It include half adder module PB. Let me explain what exactly it is. We are including half adder. Why we are including? Because I will need the definition of the half adder in the test bench. This is how a test bench you can visualize in a real life. Okay, it's just for visualization purpose. Okay, let's say you are verifying a multiplexer. What it will involve is you have a test bench. The table is like a test bench on which you are placing your design. You are connecting the ports, and from here you apply the inputs. Apply various inputs. You get the output. Then you check whether that is good or that is bad. You check whether that is good or is that correct. Any questions so far? So with this understanding, first thing we do is what is the first thing we did? If I wanted to verify a design, I place the design on the test bench. This table is like my test bench. See, this table is my test bench. What am I doing? I am placing this design on the test bench. That in Verilog terminology, it is called as instantiation. That word is called as what? Like placing my design onto the table is called as instantiation. So let us understand what is meant by instantiation. This is called as instantiation. You write the module name, you write the DUT. This is called as instantiation. Is placing the laptop is sufficient, only sufficient? What else you have to do? You have to connect them. So you have to connect the ports. You have to tie the, my laptop has some ports, my table has some ports. I need to tie both of them. Understand? See, these red lines you see, red dots do you see? These things you see? I need to connect them. Only then I can give the inputs, right? Without connecting, how can I give inputs to my design? So for that purpose, what we do is, what all inputs I have to apply? A, comma, B. I declare them as reg. Right now, just understand that we have to declare it as reg. Outputs I have to collect, which I call as sum, comma, char. I just connect the same things here. A, comma, B, comma, sum, comma, char. These things are the ports present in the test bench. Things that are declared in the test bench that I am connecting to my design. Once you have done the connection, will it verify automatically? Let's say if this is my table and I place it on that, will this design gets verified automatically? No, right? It will not get verified automatically. What do I have to do? I have to apply the inputs. I have to apply the inputs. So let's now understand how we are going to apply the inputs. For that, Verilog has a construct called as initial. You remember there are 50 constructs. One of them, those constructs is initial. I told you, right? Verilog language has 50 words you have to learn. Let's not use the term construct, words, so that it will be easy for us to understand. Okay. Like in English, going is a word, coming is a word. In Verilog, there are 50 words which we are going to use. That's all. After 50, you won't use anything more. So one of the words we are going to use is initial. Initial is like, as the name suggests, what you want to start initially. What is that you want to run initially is this. So here, I want to make A equal to 1. I want to make B equal to 1. After some time, I want to check what is the output. For checking purpose, I'll do one thing. Now again, display is one more word, which is similar to printf in C language. In C language, are you familiar with printf? Display is very similar to that. It displays the value. It's A equal to percentage B, E equal to percentage B, A comma B. A comma B. Similar to this, apply more inputs. How can I do? I'll copy line number 10 to 14. How many lines is it? 5 lines, right? What is the GVim shortcut to copy those 5 lines? 5 YY. 5 YY. I will copy. I came here, I paste it. Now what I will do is, I'll change it to 0. Like this, one zero, something like that I did. The only thing is display I missed it. So how this code works is, as soon as, see, when you made A equal to 1, B equal to 1, where does this inputs go to? This will become 1. This will become what? 1. Do you agree? It's like I have connected wires. Connected wires here. I made this equal to 1, this equal to 1. What will happen to these points? They will also become 1, right? Because they are connected through the wire, they will become 1. When you make it 1, 1, what will happen? Some output will come. Where does that output come in my case? Essence. I am just displaying S commas. You understood? I have applied A comma B. Now I will check whether S and C is coming properly or not. To run this, I'll open QuestaSim or ModelSim. Both of them are same. For a Verilog language perspective, both QuestaSim and ModelSim are same. Whichever directory I am developing the code, I'll go to that folder. Copy address. When I go there, what will I do? CD brackets, flower brackets inside that. CD flower bracket inside that, just paste it. Control V. Enter. If you do PWD, where are you right now? In that folder where I am developing my files. Now, what is the first thing we have to do? We live work. Actually speaking, in Questa sim I don't need to do. In model sim you have to do this. Then we live work. Now when I did we live work, what happened? Work library got created. Do you see the directory got created? Earlier was it there? The work library, was it there when I started the project? No. Why are we doing this work library? I'll show you now. Now when I do vlog, TB half adder, it got compiled. Few things got created actually. See, these are in its internal format which you don't understand actually. This, what is the format of these files, we don't understand. But what it has got actually is the definition of half adder, definition of the test bench, everything is present in these files in its own format. So what are we done with right now? What is this stage is called as? Is it compilation, simulation, or what is it? Vlog means what? Compilation. What is the next stage after compilation? Elaboration. Vsim. Okay. In my tool, the one which I use, I have to use some separate commands. You don't need to do, but I have to do. These things, these two words I'm using, right? You probably don't need to do in your model sim tool, but in model Questa sim, the one I am using, I have to pass those options. For now, you can ignore them. Okay, for you the command will only be vsim space tb. That's all. When I run it. Now what is happening? Elaboration is happening. What is meant by elaboration? Tool is trying to understand the structure. It has come up with the structure. This is what tool has understood. Please go through that. What is the structure tool has understood? Tool has understood that at very top level, what is there? TB is there. Below TB, what is there? DUT. What is DUT actually? Design and test. What exactly is design and test? It's half adder. Name of the half adder is DUT. And below DUT, what is there? Two assign statements are there. You remember the Verilog code I developed using assign statement, the data flow modeling I said? This process where tool came up with the structure is called as elaboration. See, till elaboration, it didn't knew that this was the structure. It only know that there is a TB, there is a DUT. When we did elaboration, it has done this connection. Once it knows the structure, now I can run the simulation. Run hyphen R. Is it behaving correctly? I will copy it. Tell me, is it correct? Which line number is correct or which line number is wrong? First one is correct. Yes. Second one? Wrong. Third one is also wrong. Right? So where do you think is the mistake? Is the mistake with sum or is the mistake with carry? Carry, right? So this process is called as debugging. What we are now doing is called as debugging. We are checking the outputs, whether outputs are coming as per my expectation or not. Is it coming as per your expectation? No. So now we are doing debugging. Okay. This is called as finding the issue. We have found the issue. Okay. Then let's analyze the issue. Where is the mistake is coming? Now if I go to the code, do you know where is the issue? Okay. Now tell me, will you debug sum or will you debug carry? Carry. So that is what is important. You should not debug a place where there is no issue. Should debug only the place where the issue is present. So you should debug line number 8, not the line number 7. That is important because if you start debugging everything, there will be thousands of lines. You don't know. You can't check everything. So if you can clearly see that there is an issue. What is the mistake? This is called as fix. What we did now is called as a fix. Issue happened because there is some mistake in the code. So debugging is a process of identifying what is causing the mistake to happen. What is debugging? The process of identifying what is causing the mistake, things to go wrong. Then what we did now is called as a fix. We are fixing. Then once you fix it, then you again run this process. See, we have to run these steps again, right? Do I have to run line number 3 again? Not required. So only these steps I have to run again. So what I'm going to do is, I'm going to copy them. I create one file called as run.do. Then I can run this. So to run this, do run.do. So what is the advantage or benefit of doing this is I don't have to run each step. I have to run. I can put together multiple steps and do this.
ये तो बनवाए है ना ऐसे खाली इनके तो सेफ्टी टैंक जहाँ की वहाँ टंकी बना दी वहाँ खादवा बना दी और ऐसे करते ही तो ऐसे सनाई किया वो करते भी नहीं ऐसे पत्थर सजाया हुआ था ये लोग तो करेंगे ना इसको भी तो कर देंगे खादवा तो बचा ही नहीं उसको भी प्रॉब्लम ही नहीं होगा बाहर आएगा नहीं उनके तो कौन है आने में तो टोटल कौन है ना जा पाओ इसमें दोनों आने वाले हैं इसमें आपके नाने वाला भी दोनों साथ में हां